An example, we have here an example. A concentrated load of 45,000 pounds acts at foundation level at depth of 6.56 feet below ground surface. Find the vertical stress along the axis of the load at a depth of 32.8 feet and a radial distance of 16 feet at the same depth by using the Boussinesq and Westergaard formula. For Westergaard formula, the Poisson ratio is equal to 0. Neglect the depth of the foundations. We have the concentrated load, so meaning this is Q, no? Acts at a depth of 6.56 below the ground surface. So we are to neglect the depth of the foundation. So we are to neglect this one. Then find the vertical stress along the axis of the load at depth of 32.8 feet and radial distance. So meaning this is Z, no? This is Z and radial distance of 16.4 feet, or this is R, no? So for the solution using the Boussinesq equation, so this is the formula, this one. So we have to determine the R over Z ratio, no? This one. Then using the known values and simplifying. Yes. So using the, your R is equal to, pila na siya? Pila to siya ganina? 16.4. And your Z is equal to 32.8 feet. So that if R over Z, this is, I think, 0.5, no? Your R over Z is 0.5. And substitute in here, your Boussinesq coefficient is 0.2733. And using this equation, your stress now at that distance is 11.43 pounds per square foot. And using the Westergaard equation, this one, no, with mu is, sorry, with mu is, why? With mu is, with mu equal to 0, so this reduces to this one, no? The Westergaard equation. Then R over Z is 0.5. Substitute in here. So your coefficient, Westergaard coefficient is 0.1733. Then solve using this formula. Then the answer is 7.25. Your Z is 32.8, no? As given in the problem. This one, Z squared, 32.8 squared. 7.8. Notice that using Boussinesq equation, mas dako yun, no? This is conservative value. Mas dako siya kaysa sa Westergaard equation. And we have the line loads or strip loads, no? So the line loads, by applying the principle of the above theory, so this one, if there is a load, what is the line loads? What is the stress at this point, no? The stresses at any point in the mass due to line load of infinite extent acting at the surface may be obtained. The state of stress encountered in this case is that of a plane strain condition. The strain at point P in the y direction parallel to the line load is assumed equal to 0. Ito na ang laptop. The stress sigma y normal to the xy plane is the same in all directions, in all sections, and shear stresses in these sections are 0. The vertical stress at that point, at point P, may be written in this formula, no? Where I sub z is the influence factor equal to 0.673 at x over z is equal to 0. So we have here a strip loads. Okay, let me have mag charge sata. Okay. We'll continue, no? For the strip loads, such conditions are found for structures extended very much in one direction, such as strip and wall foundations. Now, foundations of retaining walls, embankments, dams, and the... So, example of the strip loads are the wall foundations, foundations of retaining walls, embankments, dams, and the like. No. We have here a from here, no. This is the strip footing. Then we are to analyze this point here. So mahimo na siyang kani. What is the kani? What is the stress at point P? No? You have here the strip stress Q. Then what is the change in stress at point P? Hello? Hello? Kinsa ni palihog?